We have two more topics to talk about before the end of class. And those topics are related to, well, how could you start to run Python programs locally? So far, we've been focused primarily on Google Colab as one area where we could write Python code cells. But know that you can write and run Python programs on your machine as well. Here we see that we've been working in a Google Colab notebook. We use code cells and text cells. We took a look at the settings in the menu. When I ask you to submit a deliverable, like I mentioned last class, I'll be asking you to submit a link to your Google Colab notebook through some Google form, but also asking you to download the actual notebook and file and upload to Canvas. After downloading a notebook, you could definitely just upload it to Canvas and you don't need to run it locally. You won't need to do what we're about to do. But if you're interested, for example, if you're going on a trip, you won't have access to internet, and you want to do some programming on your local computer, you might want to set up your notebook environment locally using the notebook setup from our development environment setup guide that I linked you to in today's agenda. So sure, we have like this IPYNB file that got downloaded, perhaps into the downloads folder. And you could just like upload this notebook file to Canvas and call it a day. However, if you wanted to do your development locally, I'm going to share with you very quickly how we might do that. First, you would need to install a few tools. So if you want to run these IPYNB files locally, you'll first need to consult the local development environment setup guide, specifically the notebook setup. So in order to run a notebook locally, you will need to use the command line. You'll need to have Python installed on your computer. And then afterwards, we could use what's called the Jupyter notebook. So Jupyter is a Python package like Spotify, like Detoxify, like Pandas that we've referenced briefly. And so after we install the Jupyter package locally on our own computer, that's what's going to allow us to run a notebook locally. So there's more that goes into this kind of installation, but one place where we could run these notebooks from is the command line. And so the command line allows us a different interface into your computer. Has anyone ever used the command line before? All right, so this may be new to you. When I was growing up, we had an MS-DOS computer. So it was like before Windows. So before like the graphical operating system where you can drag and drop files, in order to just play my game that I wanted to play when I was 7 years old on the computer, I had to run a command to launch that game. So anyway, just a little trip down memory lane. But the point is here, with the command line, we can navigate the file system. Like, where are we right now? I'm in my downloads folder. We could move or change directories, like moving up a directory, changing directories, and asking where we are. Now I'm in my home folder, could navigate to the desktop, and you'll see more examples of using your your terminal if you follow the command line computing exercise. So you'll see, if you want to get involved with local development tools after installing some things, you'll see a link here to a command line computing exercise, which will help you get up to speed with using the command line as an alternative way of interfacing with your computer. And that exercise will show you some of these commands, like navigating the file system, like, hey, let's move into our downloads folder where I downloaded some files, list the files there, kind of like we did in our Colab notebook already. Here I've downloaded my Hello World notebook. And so after checking what packages are installed with a pip list command, like we took a look at in Colab, the pip list will show us what packages exist locally. And because the Jupyter package, I've already installed it locally, that allows me to now leverage that package to run this notebook. And so all we need to do to run a notebook is Jupyter notebook. And that will start a local development server to run notebooks. And so if you want to do your notebook development locally, you could always access these notebooks through a local server in your browser, and open them up and run them in the same or very similar way that we would do in Google Colab. So the interface looks a little different, but we can run cells and add code cells and text cells. So if you'd like to start getting set up with local development, I think just trying to run a notebook locally could be a good start. You don't need a text editor, and you might actually be able to access these notebooks directly from the Anaconda Navigator program. And you'll see more information about Jupyter Notebooks if you take a look at the development environment setup guide, specifically the notebook setup. Here's a link to more information about Jupyter Notebooks. So you could optionally get set up and then take a look at my notes about using Jupyter, and that's where you'll see installation commands, and also after navigating to a certain file path, running the Jupyter Notebook server like I just did. So here's a link to how you could run Jupyter Notebooks locally. And that's possible for us. So if you're ever like going on a trip, you want to do some coding on the airplane or something like that, you can maybe download your notebook locally. And this is, of course, after you've installed Python locally, you'll be able to do something like this. So questions about running notebooks locally? All right, again, this is optional, but I encourage you to get into some of this local development, especially if you're interested in moving on with other computer science classes. All right, that being said, I'm going to stop this local notebook and start to move into the final demo of today. In both of those examples, we're dealing with notebook files, these IPYNB files. They're kind of like a simple interface into coding, and their abilities are limited. If you take a class with me in the fall, in the business school, OPIN 244, that's when we'll get more into local development. That's when we'll leverage the benefits of local development. For example, making a web application. We can't make a web application within a notebook. But if we start getting into local development tools, we can actually write our own web application and leverage other benefits of the local development environment. We could locally create like a Mario Brothers style game in Python, but we wouldn't be able to run that kind of game in a notebook. So I just want to give you the sense that notebooks allow us to do a lot, but are still limited. And so if you're interested after this semester is over in continuing with some more local development, for example, with me in OPIN 244, then that's when we'll deal more with the local development environment, and we'll make web applications and stuff like that. And we won't be able to do that kind of thing with notebooks. So what I hope you take away is that notebooks help us do a lot, but it's not a complete set of capabilities. There's additional things that we could do locally that we can't do in notebooks, like creating a Mario Brothers game using the Pygame package. Anyway, that being said, if you're interested in getting more involved with local development, I'd encourage you to go through our development environment setup guide, specifically the full setup. If you want to be a pro developer, you'll definitely do this. And some of you have already asked me, how can I get started with local development? So you can follow this full setup guide, sign up for a GitHub account, download a text editor like Visual Studio Code or an IDE like PyCharm, and then get familiar with the command line via the command line computing exercise. Download Anaconda, which gives us access to Python and Pip, and also download some tools called version control tools that will help us download code from GitHub directly and then upload our code to GitHub. So we won't be getting into a lot of these this semester, but they're here for you, and these guides are here to guide you. And I'll give you a demo with our last 7 minutes of class into a locally running Python application that I've written. And so here's how it would work. For this last demo, I'd like to draw your attention to this run the app exercise, which after you optionally download the full setup, you could try on your own. So I think one cool, fun thing to do for homework, if you're interested, would be to see if you could download all the tools for a full setup, and then see if you could run the following Tic Tac Toe app that we're going to get into together. So if you check out this run the app exercise, you'll see more information about it, including some prerequisite exercises like this local version of the Hello World exercise that will help us run a Python program locally. Then we'll see this link to a Tic Tac Toe app. So clicking through to this Tic Tac Toe app will bring us to I guess an exercise page that will give us more details about the exercise, but also a link to the source code for the app that I'm about to run for you. So if you're interested for homework, I'd encourage you to optionally try a full setup and then try to run the Tic Tac Toe app. So follow this exercise and it will involve this repository. So on GitHub, so far we've looked at our course repository. Oh, we only have 5 minutes left. Okay, let me do this abbreviated. GitHub is a place for us to share code. So when people are writing those third-party packages like Detoxify, Pandas, and others, we could and should hopefully find that source code on GitHub somewhere. And that's cool. We could look into it. That being said, if we want to collaborate with other developers, we can upload our code to GitHub and they could download the same code. And that's how development teams work together, is by sharing their code in a place called the GitHub repository, which is just like a set of folders and files that have some Python code in them. So with any repository on GitHub, a repository is like a coding project. After you've logged in with your GitHub account, you should be able to star or fork the repository. Starring is just like, hey, I like this. Fork is like, hey, I want a copy of this code for myself, so let me copy it. There's some weird terminology in version control, including fork. But anyway, any given repository or coding project is just a bunch of text files and folders, and we see some of the files and folders here. And each project or repository on GitHub should have an introductory document called the README file, which is displayed by default. And a README file role is to give instructions for how someone else could download and run the code provided in this repository. So I've already downloaded this code for the Tic Tac Toe game. You'll see that the code for this game spans many files. So when our apps start to get more complex, it may be necessary to take them locally. Maybe we've reached the limits of what we can do in Colab. And as you work on more complex apps, it's most likely that you'll be working with a GitHub repository with many Python files, like this game file that I wrote to play a game of Tic Tac Toe. So the way that this works in 2 minutes, I guess, is from the command line or using some kind of version control tool, we would actually download this folder of files on our computer. So here you see I've already done that, and through a tool called the text editor, which is like our text cells in a notebook, we have access to read text files, including this README file and Python files like this game that we were looking at on GitHub. So after following the steps in the README file to make sure that this app has all the packages it needs, doing various pip commands like pip install, we can now start to play the game using certain commands shared with us in the README. So let's play a game. And the way that we'll run a Python program locally is with a Python command like this. There's two different styles of running Python programs locally, but this is one of them. And here we're using the Python utility that must be installed on your computer in order for this to work. So when you install Anaconda, if you like to do that, it'll give you access to Python. And so that will allow us to run a local .py file. So now let's play a game together as our class for the last thing that we'll do in class. So with this game, we get to choose whether we want 2 humans to play, doing like a pass and play, or 2 computers to play against each other. But what we'll do is we'll start with a human player, and that will be us. And I'll be asking for some volunteers to give us some Tic Tac Toe choices in a sec. And then for the second player, I coded up 2 different players. One is an easy computer player that just makes random selections. And so it's super easy to beat that easy computer player. But for fun, I also coded up a hard computer player, and that's the player that we'll play against now. I think the hard computer player is impossible to beat. We could hope to tie though, so let's try it out. All right. So, as you can see, we can get inputs from the command line into our program, and we'll learn how to give inputs into a code cell in Colab as well next week. But here, what we could do is choose one of these boxes to play. So we're X and let's play. So I love a volunteer. Which box should we start in? B2? All right, is that an opening move that's going to lead to victory? Let's see. B2. So now the computer's actually thinking about its next move, evaluating all potential combinations. And we see after we went to B2, the computer went to A1. All right, next move. I love a volunteer. A3. All right. So the computer thought really quickly. It went, I think, to C1 maybe, or it blocked us. So we tried to win, the computer blocked us. I think at this point we have to go B1 or else we lose. So now we'll do it. And now, I don't know, it doesn't really, I don't think it matters what we choose. We're in forced tie state. So, I don't know, like C2 maybe. And we had no choice but to end in C3. So, hey, that hard computer player, that was a fun game. And if you're interested in local development, maybe you could use this as a motivation to run something locally. And if you need help, let me know via Slack or email. Peace out. Have a nice weekend. See you next week. We'll actually start coding, which should be fun. Have a good week.
Thank you.
Yep.
Thank you.